All right. Well, welcome everybody. It's good to have everybody here today. We are going to give you a little bit of a talk on integrating AI into your smart applications. So give me just a second. I will get this running. Is that coming up okay?
Yep, looks good.
Fantastic. All right. Well, hi. My name is Michael West. I'm an application developer with Catapult. Been in the application dev space for roughly about 20 years now, so kind of a long time, and have an educational background in data analytics and machine learning.
Hi everyone, I'm Roy Concepcion, and I'm a senior consultant with data and AI practice. And yeah, my background is also in app development. Started with front end and mobile apps, but recently been doing a lot more integration with Azure and with the cloud and microservices. So yeah.
Okay, well, good deal. Well, let's jump in and get started here. So today we're going to give, our high-level agenda is just to give kind of an introduction overview about AI, just share some of our thoughts there, and then we'll kind of dive into a couple of facets, a couple of offerings that are out there. We'll look at Azure Search, cognitive services, and machine learning studio. So, there's a lot to AI. It's a big topic, and it's one of those subjects that over the past couple of years, really, as people start talking about AI, it's hard to understand what that means. So that's a big, large canopy of ideas, and so there's a lot of there's some misconceptions. But there's also just people know a small area or know one facet of it. So we're just going to kind of give a real brief overview of some of the tools that are within under that umbrella. So when we're talking about AI, you can kind of carve it up into different areas. And so, one of the areas is going to be machine perception, and what that is just it's having machines, it's having computers emulate how we sense things. So whether that sense is actual touch or whether it's listening, being able to listen to audio files and convert those audio files, doing computer vision. Where we're teaching computers how to actually look at an object, be able to understand what that object is, where it's traveling, the motion that's happening in an image, all of these different type of areas. So then we have kind of the hot topic of today, which is machine learning. It's often you'll often hear that term thrown around, and that comprises of supervised learning, reinforcement learning, and unsupervised learning. Supervised learning is kind of your traditional classroom sense, where you imagine you've got a teacher. The teacher is teaching the student something. The teacher knows the right answers. And the students, is asked a question, gives an answer, and then the teacher lets the student know whether or not that answer was right. And so we use a lot of those type of models in being able to create anything, linear regressions, kind of line of best fits on the data, classifications, things of that nature. Reinforcement learning is a little bit different of a kind of a beast there. You want to be able to have a computer. The computers, you're not actually teaching it directly, but you're setting up a reward system. So the computer is programmed so that it values rewards, and so it wants to get as many rewards as it can, kind of over an event horizon. And so if you can imagine your robotic vacuum cleaner at your house, and it's traveling around your floors, it'll get a reward for picking up a little piece of dirt. And so the more times that it gets that, it likes to pick up dirt, it gets a reward. Then it'll probably get some large reward for being able to come back to the base and be able to charge back up. Unsupervised learning is looking at data and letting the computer run wild with it, right? So, but it's looking at the relationships in data, looking at being able to cluster data, understand some of the patterns within that. natural language and speech processing that's taking text and speech, doing sentiment analysis, things of that nature. Knowledge representation. That's kind of the old, the inception of AI was knowledge-based systems, and those are rule-based systems to where we have some ontology, some logic that we're trying to figure out. Kind of an early one was SOAR, where we have a set of, we have knowledge that we're able to build off of and to have the computer make decisions for us. And originally that was thought to be that was going to be one of the more challenging aspects of AI. Computer vision, it's, the funny story is that computer vision was given to an undergraduate student at MIT to go do over the summer. Just go ahead and get that solved, right? While they were working on a knowledge-based system, and ultimately that ended up being very far from the truth. The logic-based systems were a little bit easier to handle, and computer vision in a lot of ways is still challenging for us today. Then we got advanced planning. So that's planning, scheduling, logistics, where we're doing some kind of value iteration, trying to figure out some algorithm that is able to create a plan, create tasks in the most optimal way. And then we have in robotics, and those robotics can be both physical, but they can be software as well. So we can have software assistants that are helping us out with our tasks. We can also have physical robots. One of the projects that I'm working on is we're creating a robot to go farm trees. So we're actually creating a physical device that moves in between the trees, and the robot has an arm, that's going to reach up and grasp fruit. And then on the computer, the thinking part of that, we have the robot it also uses computer vision to be able to detect the fruit, see which branch is on, and deep learning processes to be able to determine whether or not that's a fruit that needs to be picked. So a lot of that, there's a whole lot of different areas in here that it's a pretty big topic, right? Sorry, I got a little ahead of myself there. When we're talking about technology in general, though, there's just in the scope of humanity, there's been a couple of really big inventions that have come around, and sometimes it's difficult to start using those right off the bat. And an example of this is during the Industrial Revolution, we had steam engines that were powering factories, and electricity came around, and it was a much more efficient mechanism to be able to power things. So originally, what they did was, and the way that manufacturing factories worked with steam engines, you had one centralized place where you're feeding in coal. That coal is powering the whole factory. So you had one main shaft that was delivering power to a bunch of different machines that are all over the factory. And so ultimately, if you're going to run one machine, you really had to power up the whole factory. So there's not the most efficient way of doing it. To switch over to electricity, what they originally did was they just pulled out the coal burning furnace and replaced it with an electric machine. They didn't actually find any efficiency gains off of that, just because how it was structured. So we had to go in and re-architect the way that we did things. With electricity, we're able to take lines and bring them directly to workstations. And those workstations then, had little smaller machines on it. They could power up and do their work. It was a whole lot less power that was being used, so we were able to do it more efficiently. And we saw that also in the computer age in the 70s and 80s. Computers were coming around; they were becoming more and more ubiquitous across. Everybody started having computers. Suddenly, kind of famously quipped that you see the computer age everywhere, but the productivity statistics, right? And so we had to learn how to use the technology and how to bring it into the fold. You can't imagine an office nowadays that works, without a computer or without using spreadsheets, something of that nature. So that was a challenge that we ultimately kind of faced and started figuring out in the 90s. But we have a similar situation with AI too. And there's been a couple of AI winters that have occurred where we had the big promise of AI. It was coming out, but then it was harder to realize. And so one of the cool things, we need technology to be effective. It needs to be able to work and do the job, but we also need it to be accessible. And so one of the cool things that Microsoft is providing us here is kind of a suite of intelligence services that we can hook into and start using within our applications. So just to give kind of an example technique of what, an example technique of AI and how computers might be able to look at a problem. And we won't go too deep here. It's just a kind of fun little problem. But, when a computer looks at a problem, he's going to be working off of data. And in this sample, we see that we've got, two different clusters of data. We've got red dots and blue dots, and they're on different sides of the screen. It's pretty easy for us as people to come in here and look at those and be able to tell that there's probably two things there. And we could remove the colors and it'd still just be dots, and we'd be able to see that there's two different objects. And this is pretty easy for a machine to be able to do too. So, with the machine, he wants to be able to come in and draw a line that's going to separate these two things in kind of the most robust way to make sure that future growth is still categorized correctly. And so we call that linearly separable. So we can draw a line through it. But there's some data that doesn't present itself that way, so it's a little bit more challenging. Here's an example where we've got a cluster of data, but then we've got a ring around it. And in this problem, we don't have a way to come in and just simply draw a line through it. So anywhere that we decided to draw a line, we would have a significant amount of blue dots on both sides of that line. So it really wouldn't classify that very well. So that's kind of a challenging problem, and to be able to figure this out, some really smart people sat around and they tried to figure out a mathematical way of being able to come up and solve this problem. And ultimately, what they did was they added a dimension to it. And here's a little bit of math. I mean, this is kind of forgettable, right? We won't go through that, but really, what they did was they took. They took some factor and they multiplied each one of the data points by that factor. And so they were able to introduce a dimension without changing the nature of the problem. And so kind of what I mean by that is if you imagine an algebra problem, you balance the left side with the right side, you can scale both of those up in different ways. But as long as it's the same factor, the relationship between that problem stays the same. And that's what they do here. And by doing that, it raises up the red cluster, right? We can now draw a line through it. It's back to being a linearly separable problem, and it's it's one that can be solved now. So this is all kind of cool stuff, and I just wanted to throw that out there just to give an example of what a technique in AI is. This is an older technique, so it's SVM that it's used to classify things, but that's not the type of problem that application developers are really going to be working with, right? So we're not in that space. It's not the type of problems that we like to solve or have access to solve. So we want to be able to use some of these things that are out here, and build off of research like this. But we want to be able to use that within our own apps, right? And so, so there's some tools that Microsoft has been able to give to us. One of them is Azure Search, and we'll go into some of the others here in a second. So Azure Search is, if you think about nowadays, all kinds of applications have search boxes, and we see search all over the place. We've grown very accustomed to having search. So it's just one of the common things that we do. Building a search feature is, we can do it. It's not the hardest thing in the world to be able to go create a search feature that reads the text or reads full text, searches a database, something like that. But that's kind of the simpler case. the simpler scenario where we have, a limited amount of searching that we're doing. Once you start getting into more complex features, and for the old school days of using Lucene or DT search, there was a lot of programming that you had to do just to get it to start building indexes. So to build a really full featured search is quite a challenging task. And so what Azure Search does is it brings us a lot of that goodness in here, and brings a lot of this kind of rich features into our application that we can consume these without having to worry about all the details underneath. So Azure Search takes a lot of different data sources, and that's whether that be SQL or Mongo, blob storage. There's a wide variety of data sources that it can pull from. And it pulls from that data, and it can take just regular text. It can take database records. It can, if let's say we're pulling from blob storage and it has different documents in there, it can pull Word docs and PDFs and JSON text, PowerPoint, a wide array of document types. And the first step that it does is something called document cracking. And in document cracking, it's just looking. Each one of those files has a different format, and so they understand how to go in, reach into that document, pull out the text, and then start being able to use that for further the pipeline for processing. So once it's actually extracted the text out of these documents, then you can start applying different skills, cognitive skills to it. You can determine what you want to do with it. One of the things that you're able to do is, we can extract names, and kind of names of entities, right? So if we were to index this PowerPoint right here, you'd have a lot of different text that was in this document. One of the things that you would find is that there's, there'd be the words Roy and Michael in it. And so it would be able to look at those words and say, hey, these are kind of special. And these words mean something. They're names of people. Right, so we can extract names, we can extract location names, organizational names, different things like that. Key phrases, we can translate the text. If the text came in one language, it can be translated to another before the index is built. Facets, we can have kind of a hierarchical filters on our data. So there's a lot of kind of rich features there. One of the cool things too is OCR. So if you imagine you've got a PDF, and that PDF has some images in it, and those images have some text written on the image, it'll apply OCR to be able to read that text and make that accessible too, which is kind of cool. Just to be able to click a checkbox is really all you have to do, and then now all of a sudden it's reading images. So once it starts applying those skill sets, it'll build an index for us, and you can build that index various different ways. You can set a schedule to be able to go out and build once a day or once a week or whatever suits your business need. On one of the projects that we had, we utilized this our business rule is that anytime that we updated a record in the database, we needed to have our index updated as well. So if a record was saved, the index was updated. If it was deleted, then we also needed the index built at that time. So when we did that, we would send, we'd save the data, then it would trigger an Azure function, which saving that data would trigger an Azure function. It would then go off and update the index. And then that way, the data was always up to date and on time for our application. And then at the end of the day, what we're going to have is some search features that we get to, really, I don't want to call it for free, but, we get a lot of features that we get to include into our application just off the shelf, right? So we'll have fuzzy search, geospatial support, proximity search, be able to use synonyms. It'll do autocompletes and suggest search for. So a lot of features that just come in here that and we can send OData queries and to be able to kind of actually do the searching as well. So we'll have a field and say, hey, this field is like some piece of data or some term. Maybe it's greater than, less than. So we can build up complexity on our end on the searching as well. But a lot of features that we can just include into our application So it's pretty cool stuff. Roy, do you want to tell us a little bit about cognitive services?
Yeah, before we get there, I would say, you see all these cool technologies that you mentioned, OCR, extracting names, key phrases, all these different tools. Before it was really expensive. If you say you have none of this, what is the cost to get this up and running, right? You have a lot of different uh, tools that are very specialized. If you're doing something in Vision, you got to learn OpenCV or, natural language toolkit if you're, working with NLP and lots of different tools. And Microsoft provided a way to answer that accessibility problem. Let me take over the screen real quick. So what is Microsoft Cognitive Services? So Microsoft gave a suite of tools that will allow you to integrate a lot of this functionality really quickly in your applications in a simple to use manner. So it's a collection of pre-built AI models. You don't have to deal with the training and the retraining and all that, and learning all those different technologies that we talked about to then use that in your app and get a lot of stuff in. Most of them are created with simple REST APIs. So if you know how to make an HTTP request, most developers do, then it's pretty simple. They also offer SDKs in many different languages, and that helps get a lot of the tools running very quickly. So cognitive services as a whole mainly deals with those 5 branches that we had talked about earlier. If you remember that pie chart that Michael showed of all the different factions of AI, they're trying to hit as many of those as possible in a way that a lot of people can use, right? So with vision, you have computer vision, recognizing images, recognizing faces, forms, metadata in your videos. Speech, translation to text or translate to another language, recognizing who the speakers are even, language, that's that NLP we talked about, understanding what the text is saying, get some ideas on what is being said with some analytics and things. There's this whole knowledge or decision branch, which is really about that machine learning, making those decisions, figuring out what are you getting out of your content and how to apply that moving forward. And then search, which Michael went over. You get the search, you get the autocomplete, auto suggest, a lot of different tools. And this is just a small subset of everything that cognitive services brings. Like I said, there's over 100 different models and things, so there's a lot of tools in your toolkit. When you're creating cognitive services in Azure, it's actually really easy. All you have to do is say, give me a cognitive services, give it a name and your pricing tier, and you can start at the dev one just for testing, and you're good to go. It's really that simple. And then you get an endpoint and your token, your authentication token, and that's it. So I'm going to show off a little bit on cognitive services. So here I have one example of one of the API calls that you get within cognitive services. This one is doing a text analytics. So in this example, we're showing off the opinion mining. So you have a text, say you want to see a bigger understanding of how all your reviews are going, say on Yelp or something like that. And you just want to get an idea of how are people feeling about your product, right? So in this case, it's just a simple endpoint. You pass in your token and a list of documents. So your documents can be something from a blob store or a SQL, just like Michael was talking about. It can pull from a lot of different data sources, and you can kind of get an overview of what's going on. So let's send this request and see what goes on. So in this case, we have this one document. It's a coffee review, right? Excellent espresso. I had a cappuccino and it was delicious. Currently, you can walk up in the order and et cetera, et cetera. So in the example, we get back an overall sentiment saying, okay, this is positive, right? This is a good review. Gives you a confidence score, and it breaks it down by each type. And really what it's doing, it's actually analyzing each individual sentence in the paragraph. So in this case, each sentence would have its own confidence score, and you can review those and save that data. And you can do that over, a big chunk of say you have a blog with, hundreds of reviews or hundreds of comments. You can kind of get an overall sense of what's going on and what can you improve. And Another cool thing that Cognitive Services brings here is that you get a model version. And this is the AI model that Microsoft's running and when it was last trained. So you can get an idea of, okay, I have a baseline model. I can save this data, and if I were to run it over time, I can see the different model versions. I can see, okay, what is this working for me? Is this improving? Do we need to make our own model? We're right now we're just starting out. We don't have anything, but if down the line we want to get there, we can add machine learning and kind of some other tools. And this is actually something that we use in our own AI Accelerator. One of the tools we have here to kind of get people started with AI. In this case, so the AI Accelerator is just our kind of little sample app here. In this case, we're doing a audio source where we have a blob store where we're saving audio clips, and we can actually get the text out of those clips to then move on down the line. So I'm gonna give that a quick shot. Hey everyone, welcome to Modern Data Culture Summit. I'm glad to be here. So just save that. And then it will automatically show up in our blob store. And then as we're passing that in, so then after a short time, it would just send it pass on through that API service, and then we get back the text. So in some cases, maybe not perfect, but you can work on you can use the model to then tweak as you go. And then this could be passed into either sentiment analysis or some other text analytics to get some more info. So, you could use this, say, if you have, call center data, you could, feed in all the different call center calls, get some analytics going with that. Or you could use the speaker recognition where you already predeterminedly get your employees or coworkers already filtered out so that you're not, using that as bad data into your other models or other tools. Just to show you a quick little bit of how that goes in Cognitive Services. So here's a little bit on the back end. In this case, we're using the Cognitive Services API SDK for .NET. Very simple. You just import the NuGet package and just call it in here. Like I said, all you really need is that subscription key, which is that key token you get when you create the service. Region, you can have different regions as well in Azure. So if you need to create, you need to handle data globally, you have many different centers and things, then you can do that. And in here, we're just doing a very simple opening our MP3, doing our stream reader, and then just passing it into the speech recognizer. So the speech recognizer has a couple different functions, events that you can subscribe to. So if you want to do something while it's currently processing or after the fact, you can say, okay, what do we get back? It says, oh, I recognize this as speech. Sometimes you can recognize it as music, recognize it as something else. And then, okay, we got the speech. I just want the text from that speech. So pretty simple, pretty easy. And it's an easy way to get a lot of functionality really fast. So yeah, I'm going to hand it back to Michael.
All right, good deal. Thank you. So yeah, let me go ahead and get sharing again. So while I'm doing this, one of the things that I was thinking about that, just where Cognitive Services comes in and some of the goodness that it brings. So I had worked, so we had imagine it could be any type of data here, but we'd imagine just log files that are coming in, and we want to be able to detect whether or not there was some type of event that occurred that was out of the ordinary. And so I spent quite a bit of time going in here and, trying to, find out, is there kind of a statistical deviation between this happening and this happening, and it did a lot of, put a lot of effort in there. However, there's an anomaly detector that you can consume within Cognitive Services, where you just pass it your data, any kind of time value data, and it will go in there and be able to do that for you, which is, I mean, super cool. And using the, the kind of spectrum, I believe spectral analysis, well, something similar to spectral analysis, which is really groundbreaking research that Microsoft has done here recently. So, it's up to date with the most recent techniques, and those techniques are going to grow. And there's new things that are going to come out, and so that's just something that you'll get benefit from as you integrate it into your application. Now, another thing. Let me get to the right slide here. I'm kind of behind. So when cognitive services may not, suit every need that you have, or you have a data science team, or another possibility that you have is Machine Learning Studio. I'm sure you've probably heard about that in earlier sessions, and so using Machine Learning Studio and doing ML DevOps, that's different areas. I'm sure you've been able to hear about, and so here all I'm going to do is just really peripheral to kind of look at this. This is when when Machine Learning Studio came out, I kind of kicked the tires. This is a pretty old project actually, and maybe I will share this from my desktop. Sorry, if you'll give me just one moment.
Yeah, and this would be a great option if, once you start using more AI and starting to get, okay, what kind of more customizations I need, what kind of more machine learning I need, those kind of things. What other options are there?
Right, and so here we're looking at the heart disease risk model, and really, so just to give a high level understanding of this, all it's doing, it's bringing, well, I don't want to say all it's doing, like reducing the amount of work that it's doing. It's really exciting things that are happening in here, but it's bringing in data. You have various operations that you can do to clean up data, apply transformations. Then it's going to split the data up, train a model, and evaluate a model. And right here in the middle, you've got, I'm using a 2-class boosted decision tree. And so that's the machine learning algorithm that gets plugged in, but you can switch that out for, a neural network or random forest or whatever the algorithm is that suits your problem. But imagine that your data science team, they're building something like this, and then I want to be able to use it, right? So you can publish this, and obviously there's going to be better ways of doing this through ML DevOps and going through that pipeline. But ultimately, this service, this model can be published as a web service. And so it's what I've done here. Within the studio, it'll give you kind of a test facility to come in and run this. In this case, I've got a request response, so I can click that, and a box will pop up and allow me to send in data. But I can also go into the request response page here, and it will provide something similar to Swagger. And you can actually hook up Swagger with this as well. And so it'll give you a definition of the HTTP call that you need to make. And really, like a lot of these services, ultimately what it boils down to is that, the integration for us as application developers uses a lot of the tools and the frameworks that we're used to. So it brings that within our space. And it's just a REST call that we're making. So we're going to make a post, and we're going to, for security, we're going to add the key, the API key that we have. We'll add that to the header, and it'll do, your authorization kind of paratoken security. And so it'll tell you the different types of things that you need to set up. And in my case, this is the data that I'm sending in. It's using this is taken from the UCI repository for data, which is just taking various factors in for whether or not someone has heart, a risk of heart disease. So it's giving you a sample of how that needs to be structured. So this is still kind of sample data. It'll define your data for you to let you know what these columns are, and then down here at the bottom, it will actually give you sample code, at least kind of bootstrap you and get you up and running. So it's got a C# example, a Python example, and R as well. So and from there, so this Python example, I really just kind of copied and pasted that in here. I set up my variables just to give these some type of values. So imagine that I'm incorporating this into a website someplace, and so I'm going to send in this response, and we want to be able to know whether or not a patient, maybe this is not the most realistic case, but a patient is whether or not they have these certain factors, and whether or not it's going, they present a case of being risky, having heart disease risk. So we would send this data in, make the REST call. This is just me setting up the JSON, encoding the JSON, and then ultimately passing that in as the body, and the API secrets getting injected into the headers. And then we do a request and response. We get that result back, and the result here for us, it'll give us a structured JSON to where we know how to go in and interrogate this data. The column names, the types, and then ultimately here are the value. It's going to send me back the values that I put in, and two of the columns that it has here is scored labels and scored probabilities. So that's what it's going to be adding for us, and it's going to, that's kind of the classification to say whether or not there is a risk here, and then a probability of it's one thing to say yes or no, but it can do a little bit better and say, no, we don't think this is a risk, and this is how positive we can say this is the confidence level of that prediction. So ultimately, all of the stuff and a lot of the different things that we incorporate, it really does boil down to its REST call. And so that's kind of facilities that we as developers, we can use that with with kind of innovative ideas on our part, entrepreneurial ideas in the business, and of course the techniques and know-how of whether it's our data science team or Microsoft services that are just built right off the shelf for us. So it's a pretty cool time to be in the computer age right now. We're at the forefront of a lot of change, I believe, just because we have these services that are more and more accessible to us. So Roy, I'll go ahead and turn it back over to you here.
Yeah, and one thing to add there is with the example you showed is like, oh, that's really cool. I have this model. I went from having nothing with kind of services, just starting out. I'm not doing any model training of my own or any building of my own at that point. Moving up to machine learning studio or with Azure ML, I can start creating models and start, getting a more detailed view of my data or more nuanced approach to my data. And then, you can move that even forward down the road with, Databricks, Synapse, a lot of different tools where it's like, okay, now I'm really productionalizing it to a big space, and, we can start using this in many different parts of our business. So
right,
I think
to
that's
kind of
really
meet you
cool.
where you need to be, right?
Exactly. So with that, I guess we'll wrap it up and take any questions if anyone has any. And I'll go back and share again. Looks like we have a question here. For security, other reasons, need to keep my data in-house. What options do I have for using these tools on-premise? Yeah, so actually one of the cool things that Contact Services provides is a container option. Say you want to keep everything in-house. You don't want to necessarily go to Azure for a lot of your info. They do have an option, Docker, where you could build those tools in-house on your own servers. Get some of that functionality, and using the CLI, you can do a lot of scripting and cool things there. Awesome. Well, if you're having trouble with, thank you so much for joining. And if you want to get a more detailed view on the AI, how Catapult maybe can help you with AI, we do have an AI accelerator where we come in and help kind of see where your data is, see what kind of tools are available that we can leverage and assist you in getting started with that. So. Are there any retraining options within cognitive services? Yeah, so a lot of I talked about with the models. Um, the early models, the models are obviously provided by Microsoft. You're not necessarily touching those. But if you do want to get into more customization, I know a lot of the different branches has their own kind of tools for that. Speech has Speech Studio. Especially with the speaker recognition, you can add those. Add like your employees or other people into the speech. Q&A maker, where you're making kind of your own FAQs and question answer things. There's a lot of tools and studios that allow you to customize it for your business. All right. Well, I think I'll hand it over to Samantha.
Yeah, fantastic. Thank you for your time.
Do y'all have that survey slide? It's okay if you don't. I'll have Hannah send it over. There.
Yes. Yeah.
Remember that we are doing I'm sure y'all have heard it a million times by now, but that $75 gift card, 2 of those Amazon gift cards are out right now. And the more surveys you take, the better chance you have at getting it. So if you have time to take the survey, it takes about a minute. It's very short. Sweet. Also, that'll conclude today's sessions for our tech track. So thanks everyone for joining our Modern Data Culture Summit. And if you have any questions, you can follow up with me. You'll probably see some emails from me in the near future with all of our recordings and all of that access. Reminder, if you did attend 5 or more of our sessions, let me know and we'll get you a badge, but we'll be on the lookout for all those people and we'll make sure to get those to you. All right. That'll be it. Have a great rest of your days. Thanks, everyone.
Thank you so much.